So when you look at the equation of sine or cosine and you're trying to consider the graph, it's easiest, oops, I forgot my B. It's easiest to look at it like this. This is kind of like y equals mx plus b of a sinusoidal graph. And you can do the same thing with cosine. And I'll describe the difference between the two graphs in just a second. Cosine b parentheses x minus c plus d. So you always want to manipulate them to try to get them in this form or as close to it as you can, because then you can quickly identify the key characteristics of the graph. Just like with an equation of a line, we taught you how to put it in slope-intercept form so you could know the slope is the number next to x and the y-intercept is the number hanging out by itself. Same thing here. The lowercase a is the amplitude. And if you were to graph a sine function or a cosine function, they both make the same type of shape. They make a wave. Okay. The amplitude tells you how high you go from the middle horizontal line of your graph. We call that the midline. Okay. So in other words, the amplitude is half the distance from the top of your wave to the bottom of your wave. Okay. This is a measure of the amplitude, and that's always the number in front of your trig function, sine or cosine. Okay. So for example, if you have y equals 2 sine x, your amplitude is 2. That means the graph is going to go up to 2 on the y-axis, down to -2, and then come back, because the amplitude is half this distance. Okay, so the amplitude, the bigger the number, the higher the wave goes. Okay, so you don't want to go swimming in the ocean when the amplitude is 500 feet, because, well, it's a tsunami. Okay, so B is a coefficient. Well, I'm going outside of our text. B is a coefficient that helps us determine the period. On its own, I don't think we have a word for whatever it is B. Yeah, so B is not I just forgot what I just said. What's that word? The period. B is not the period. B helps us calculate the period. And you might be thinking, what's a period of a trig function? A period of a trig function tells you how long it takes on the x-axis until the sine wave repeats itself. So sine wave goes up and down and up and down. The graph I just drew, if I put a 4 here, this graph has a period of 4 because we start at 0 on the x-axis, we go up, we go down, and then we start repeating ourselves once we get to x equals 4. So this period of this graph is 4. So B helps us calculate that period. And what you want for a formula to write down is that the period of a sine or cosine function is always just 2 pi divided by B. C is a horizontal shift. So normally sine of x, the graph looks like this. Not just normally, all the time. Sine of x looks like this, okay? But if we do sine of x minus 1, okay? I've got it in this form because I'm doing minus my c. So that means we're doing a shift, a horizontal shift. And if you remember from when we did horizontal and vertical shifts before, a -1 is kind of reverse logic. We would think that means we go back 1, but -1 means we actually move forward 1. So this is what sine of x minus 1 would look like. This one starts at 0 because there's on the x-axis because there's no horizontal shift. This one starts at 1 because I have a horizontal shift of -1. Okay, and the last number, D, that's nice and easy. We don't have to worry about factoring out a B like we did in here. We don't have to worry about rewriting it. D is always the number that you're adding to the outside. So D is a vertical shift. Okay, it's not necessarily the y-intercept, which is what we were used to seeing with y equals mx plus b. So if you have a graph of sine of x plus 1, oh, sorry, that's inside the parentheses. If you have a plus 1 outside the parentheses, instead of starting at 0 on the x-axis and going up and down, instead of starting at 0 on the y-axis, you're going to start your wave at 1 on the x-axis, and then you do your sine wave. Okay, so that's a rough sketch of sine of x plus 1. And cosine, you want to have it in the same structure because the graphs of y equals sine of x and y equals cosine of x are the same graph, except cosine has been horizontally shifted. That's the only difference. So you could always make a graph that you have in terms of sine of x the same thing in terms of cosine of x. You just have to do a little manipulation with the horizontal shift. So all those things I just said apply for cosine of x. The only difference is that the graph of cosine of x, instead of starting at the middle of your wave, you always start at the peak of the amplitude, at the top of the wave, and then go down and then climb back up. So that's one period of cosine of x, we'd say. Okay, that's a lot of information. You'll probably want to refer back to this video a couple of times. Don't be afraid to use desmos.com/calculator while you're learning all these things to test out your ideas. You can be like, wait, does A do this? And then go mess around with your equation in Desmos and see if it does shift the graph like you would think. But obviously, come test time, you want to be able to do these without relying on a graphing calculator. Yeah, that's the basics of graphing sine and cosine.